Hi, you're welcome to Tutor Your Me differential equation class. I'm on the third method now. I've started differential equation from the scratch. Yes, I have checked my page and then I'd entered separable variable. I'd entered linear differential equation, which is the integrating factor. And now we are on homogeneous. Of course, you know that if you're given expression like this, for example, let's say you're given, let me share the board into three. Let's say you're given something like this: 2x dy equal x plus y dx, and you are asked to solve this differential equation. Obviously it's a differential equation and you are asked to solve it. You cannot use separable variable. No, you can't. No, you can't. You can't even separate what is here. That's not possible. Neither can you use integrating factor. You know integrating factor, right? What we said about integrating factor is that it has to appear this way, if you remember, equals to what? Qx. And then before you talk of what? Your integrating factor. So does this look like this? No, it doesn't. So that's why we can't even use integrating factor to express this. We can't. So what do? We have to come up with another method called homogeneous differential equation. You can see now that each of the method has problem they can solve and problem that fits them. So it is homogeneous because you can see the degree there. The highest degree there is 1 and it's the same degree everywhere. So it is not that this one is having square and this one is having a cube and all that. So the homo means that they have to be the same, 1, 1, and then 1. I'm sure that's very clear. So how do you go about this? Very simple. So the major step is you have to say that let your y be equals to your vx. And when you do that, the next thing is you apply your product rule. You know product rule, right? You know product rule? So your product rule, which says that you have your dy, so v, that is you keep v constant, differentiate x, that's the x, and then you keep s constant in the next and you differentiate v. That's what you have. So you have done your product rule. Then go back to the original expression. The original expression is 2x. But what's our dy? We just showed it here now. So our dy is v dx plus x dv and equals to what? X. What's our y? Our y, we said it should be vx. So put it here, vx. And then you have your dx here. What's the next thing? So you have 2x v dx and x dv. So s is common, take it out. You have 1 plus what? V, and then you have dx. So I think we can cancel x here. Yes, it's allowed. So that I will have 2 v dx and x dv equals to 1 plus v dx. Yes, this is allowed. So open the brackets. So you have v dx, then 2x what? Dv. So that if you open this, use this to multiply this. So we have dx plus v dx. Now we need to check. Is there something that look alike we can remove? Yes. See this expression here, I think, and this look alike. So we can collect like them. So we have 2v dx minus v dx plus 2x dv is equals to what? Dx. So that from here, I can have my v dx plus ux dv equals to dx. I'm sure that's you're following. I'm sure. In case there's any part that is not clear to you, you can drop in the comment section. Okay, so what's the next thing? Where I'm saying dx, I could take it here. So I have dx and dv. So that you have dx, v, dx. And then we have 2x dv. Then ds is common, so I could take it out. I have this. It is clear to this point. So from this point now, we can employ the first method I talked about, separable variable. You can see that no knowledge is lost. So how do we go about that now? How do we go about that? So this has to come under this, and this has to come under this. So that's separable variable. So I have 1 over 1 minus this dv, and then I have 1 over what? X dx. So that's how you go about it. This goes under this goes under this. So the next thing is to integrate. You integrate. So to integrate that, you have then to integrate this, you have no, this is 2, please. So we have this 1 over v dv. Then the constant can come outside. So you have 1 over x dx. So it is easy to integrate this. To integrate this, you have to just remember that whenever the derivative of the denominator gives you a numerator, your answer becomes the ln, the natural log of your denominator. So we have, when you differentiate down, differentiating 1, that's 0. Differentiating minus v, you have minus 1. So obviously our minus will come out, and then you have ln 1 minus v. Then when you differentiate this, the integral of 1 over x is ln x. So we can include ln c there. So if you multiply, it's still the same thing you will have. So let's apply our law of log. Our law of log, the minus here can come. So we have our this equals to minus. And then we can apply the law of log here too. So this will give you half and then c. So what's the next thing I can remember here? The law of log that says that recall log ma and log mn to give you log a mn. So the same thing here, log 1 this over this is equals to log what? C times this. So that your this cancel this, and then you have 1 minus v equals to let me say c square root of this. This is what you have. So this is the same thing as 1 over 1 minus this is equals to this. And when we have this, what's the next thing to do now? So we have to but y is equals to vx from the beginning. So I can find expression for v. So this becomes this. So anywhere I see v, I put y over x. So from what I have down here, so this is equals to this. C. So in place of this, so you put 1, then you put this over this. So that you have c Okay, so when you solve this correctly, what do you have? You have this x over y is equals to this. So this is what you have. And when you have something like this, what do we do? In this case, we simply want to remove this. So how do we go about it? So we can square both sides. So let's square both sides. So we have x this, and then this will give you square, and this will give you x because the square root cancels here. So you have x square, you have x this all square here, and then you have c square x. So this s, one of these s can go, one of these s can go. So you have x over what? X minus all square equals to c square. Now, note that even this a constant multiplied by a constant, what will it give you? It's a constant. So, with that understanding, I can say that x this all square is still c without necessarily putting that. So, my final answer becomes c is equals to x all square c. Or I can even make it an absolute value, and then I have this c. See where we are coming from and see where we end the whole solving. I'm sure that's very clear. If you have any question, drop it in the comment section, and Tutoyomi will be much willing to explain to you. But it's quite simple. Bye.